Two old men walk home from work in Princeton most afternoons, side by side in no rush. One of them is Albert Einstein. The other is a thin, watchful logician named Gödel, and the people at the Institute will tell you he is the only mind there that Einstein treats as a full equal. For Einstein's 70th birthday, Gödel does not bring a card. He brings a few pages of math. They are an exact solution to Einstein's own equations, the rules that govern space and time. And folded into those pages is something Einstein will spend his last years trying to wish out of existence. The math says a person can travel into their own past, not as a story. As a result, permitted by laws we already trust. So the safest thing you believe, that time moves and the past is gone, is the very thing he quietly took apart. Every afternoon in a quiet town in New Jersey, two men leave their offices and walk home together. One of them has the most famous face on earth. His hair is white and wild, his sweater is worn soft, and strangers stop on the sidewalk just to watch him pass. The other man walks close beside him, thin and careful, buttoned into a heavy coat even when the air is warm. His name is Gödel, and almost no one outside mathematics has heard it. They make a strange pair. Einstein is warm and loud and easy with people. Gödel goes silent for long stretches, watching, turning something over that he will not say out loud. Yet Einstein told a friend that in his last years, he came to the Institute mostly for one reason. He wanted to walk home with Gödel. That is not a small thing for him to say. Einstein worked in a building full of the finest minds alive. He could have talked to any of them. Instead, he picked the quiet logician who barely spoke, and the people around them noticed. They began to say that Gödel was the only person there Einstein treated as a true equal. The only one who could meet him on his own ground and push back hard. So picture the two of them on that path. The famous one doing most of the talking. The quiet one listening, nodding, and now and then saying something that makes the famous one stop walking. Because Gödel did not think in the ordinary way. Most scientists chip at a problem from the outside. Gödel went underneath it. He had a habit of taking a set of rules everyone trusted and following them with brutal patience all the way down, past the place where the people who wrote those rules had ever bothered to look. And he kept finding the same thing waiting at the bottom. A door that should not be there. A result that was perfectly legal and completely impossible to live with. He had done it once already, to mathematics itself, and shaken it to the floor. We will get to that. For now, hold one fact. This thin, watchful man did not break things by force. He broke them by agreeing with you. He took your own rules, the ones you were proud of, and showed you where they led if you were honest enough to follow. And on those walks home, he had begun to point that same patience at Einstein's life work, at general relativity, at the equations that describe space, time, and gravity, the equations Einstein had spent a decade bleeding over, the ones the whole world now accepted as the law of the cosmos. Gödel was reading them, not to admire them, to follow them down. Einstein knew what kind of mind was walking beside him. He must have felt it coming the way you feel weather change. This was the man who found the door at the bottom of an arithmetic. Now he was somewhere down inside relativity, in a part of the math no one had thought to check, and he had gone quiet in that particular way. Einstein's 70th birthday was coming. The Institute was planning the usual things, the speeches, the warm words from old colleagues. Gödel was preparing a gift too, not a card, not a kind sentence about a long friendship, a few pages of mathematics, an exact solution to Einstein's own equations, and folded into those pages was the worst thing one friend ever handed another. Here is what makes the gift so unsettling. It was not a guess. It was not a thought experiment or a clever story. It was a solution in the strict sense that physics means. Einstein's equations are not a single answer. They are a set of rules. You feed in a description of how matter and energy are spread through a universe, and the equations tell you the exact shape of space and time that must go with it. Pour in the matter, and the geometry falls out. A solution is one complete world that obeys those rules from corner to corner, with nothing left over and nothing forced. Most solutions are tame. They describe universes that expand or sit still, that bend light around heavy stars, that match the sky we actually see. By the time Gödel started working, the catalogue of these worlds was decades old and mostly settled. The dramatic finds had been made. What was left, people assumed, was cleanup. Gödel did not look for cleanup. He went looking for a universe that was fully legal under Einstein's rules, and yet behaved in a way that should be impossible. He wanted to know whether the law itself had a crack in it that no one had noticed. And the only way to know was to find a world that lived inside the crack. So he built one. On paper, with nothing but the equations and a kind of patience most people do not have, he constructed an entire cosmos. He gave it matter, spread out evenly. He gave it the right balance of pressures and tensions. He checked every term, and when he was done, he had a universe that satisfied Einstein's equations exactly, not approximately, not in a simplified toy version, exactly. That, by itself, would be a fine piece of work. A new solution is always worth something. But Gödel was not after a new solution. He was after the door at the bottom, and his universe had one. He wrote it up. A short paper, dense and quiet, the way he wrote everything. And he timed it for the birthday, because the man it would disturb most in the world was the man whose name was on the equations it obeyed. You should sit with how personal that is. Gödel admired Einstein. He walked home with him every day. He was, by all accounts, fond of him in his careful way. And his gift was a proof that the universe Einstein had spent his life describing could do something Einstein found unbearable. He handed it over. A few pages. And in those pages was a description of a whole working universe. A universe permitted by the rules the entire field of physics had agreed to trust. In that universe, a person could leave home, travel out through space, and arrive at a moment before they left. Not in a story, as a consequence. As something the math required to be possible. The way it required light to bend and clocks to slow. Einstein read it. And then he started looking for a way out. To understand what Gödel built, start with the strangest thing about it. The thing that makes everything else follow. His universe turns, not the planets in it, not the stars circling a center. The whole thing. Take the entire cosmos, all of space, every galaxy in it, and imagine it slowly rotating as a single piece. There is no edge it rotates around, and no outside for it to spin against. It simply has rotation built into it the way our universe has expansion built into it. In Gödel's world, if you could pick any point and watch the distant matter around you, you would see it all wheeling, very slowly, in the same direction, forever. That sounds like a small detail. It is the hinge the whole nightmare swings on. To see why, you have to remember what general relativity says matter does to space and time. Matter and motion do not just sit inside space-time like furniture in a room. They grab it. A spinning mass pulls the space and time around it along with it, dragging it like a spoon dragging honey. This is real, and it is measured. Spacecraft have flown around our own planet and watched their orbits twist by the tiny amount Earth's spin drags space-time as it turns. The effect near small rotating world is almost nothing. You need exquisite instruments to catch it at all. Now stop thinking about one spinning planet. Think about an entire universe of matter, all of it rotating together, with no still ground anywhere to push back against the drag. In that universe, the twisting does not stay small. It builds. Every piece of matter drags the space-time near it, and there is so much matter, all turning the same way, that the dragging adds up across the whole cosmos. Time itself gets wound around the rotation. And here is the part to hold on to, because it is the seed of everything. In Gödel's universe, the rotation is not just a feature of space, it reaches into time. The spinning of all that matter pulls on the direction we call the future and bends it. Picture standing in such a world and pointing your hand toward tomorrow. In your own little patch, that direction is clean and ordinary. Tomorrow is ahead. But the universe is turning, and the farther you let your eye travel out across it, the more that clean forward direction gets tugged sideways by the rotation, leaned over, twisted off true. Out past a certain distance, the twist becomes severe. The direction that means forward in time, out there, no longer points the way it does where you stand. It has been rotated so far that it begins to curl back. That is the whole trick. And Gödel did it with nothing but honest mathematics applied to Einstein's own equations. He took the dragging of space-time, a real and tested effect, and he asked what happens when an entire universe does it at once, all turning together with nothing to anchor against. What happens is that the floor of time stops lying flat. It tilts, and once it tilts far enough, a road opens that should never exist. Say it plainly, because the math does not soften it. In Gödel's universe, you can come back. Not back to a place, back to a time. You can leave a moment, fly a long loop out through space, and return to that same moment, the one you left, with the version of you that left it still standing there. Your own past becomes a destination, a place you can steer toward and reach. Physicists have a cold name for the path that does this. They call it a closed timelike curve. Strip the jargon and it means a road through space and time that bends all the way around and joins its own beginning. You travel it forward the whole time. At no point do you feel yourself going backward. Your watch ticks ahead the entire trip, second after second, exactly the way it does for you right now, and it brings you out before you set off. Stop and feel how wrong that is. We do not think of the past as a place. We think of it as gone. Yesterday is not somewhere far away that you could reach with a fast enough ship. Yesterday is over. It does not exist to be visited. That belief sits so deep underneath everything you do that you have never once questioned it. You make plans on it. You grieve on it. You assume, without ever saying so, that what is done, that the door behind you is shut and welded. Gödel's pages say the door is not welded. In a universe built from Einstein's own rules, the door is a road, and the road loops back. And he did not arrive at this by bending the equations or sneaking in some exotic new force. He used the law exactly as Einstein wrote it. Take all that rotating matter, follow the twisting of time it produces, go out to where the forward direction has curled all the way around, and you can ride that curl home to before you began. There is no engine involved that we do not understand. No tear in space, no shortcut punched through some other dimension. The geometry of that universe simply has loops in it the way our universe has straight lines, and a traveler willing to make the long trip can follow one. This is the gift Gödel handed Einstein. Not a paradox dressed up to provoke, a consequence. The same equations that bend starlight and slow clocks and govern the orbits of worlds also permit a cosmos in which the past is reachable. For the people who study this, that is the moment the ground gives way. You can dismiss a riddle. You cannot dismiss a solution. The math is checked, the universe is consistent, and it sits there in the literature still, decades on, fully legal, fully solved. The standard reply, the one everyone reaches for, is that our universe is not like Gödel's. Ours does not spin that way. And that is true, and we will test it, and it will not save you. Because the real wound was never about whether we happen to live in the spinning one. The real wound is what it means that the law allows the spinning one at all. But before we go there, you should see exactly how the loop is built. How something as familiar as the speed of light quietly hands a traveler the road into yesterday. The piece that makes the loop work is something you carry with you everywhere, and it has a shape. At every point in space and time, there is a limit on what you can reach. Nothing moves faster than light. So from where you are right now, only certain places in the future are open to you. The ones close enough that a beam of light, or anything slower, could get there in time. Physicists draw this as a cone. Picture a flashlight pointed up at the sky from where you stand. The cone of light spreading up and out marks everything you could possibly affect going forward. Everything inside the cone is your reachable future. Everything outside it is off limits. Too far to touch before that moment passes. That cone is the rulebook for cause and effect. The point of the cone is now. The wide part, opening upward, is later. As long as the cone keeps pointing up, into the future, the order of the world holds. Causes come before effects. You act, then the result follows. The narrow end is always the past, the wide end always ahead. Now bring back the spinning universe and watch what rotation does to the cone. Near where you stand, the cone behaves. It points up, clean and ordinary. But the dragging of all that rotating space-time does not leave it alone. The twist tips the cone, just slightly at first. The whole reachable future cone leans, like a tree pushed by a steady wind. One tilted cone is harmless, but the universe is full of them, one at every point, and the rotation tips each one a little more than the last as you travel outward. So the cones do not just lean, they lean progressively, each handing you off to the next. The tilt deepening with distance the way a staircase descends one step at a time. Follow that staircase far enough out and the cones tip so far over that their open ends, the part that means the future, start to point partly back the way you came in time. That is the whole mechanism. There is nothing magical in it. At every single step, you are just doing the ordinary thing, moving forward into your own local future, into the open end of your own cone. The cone never lets you break the speed of light. It never lets you feel yourself reverse. You obey every rule at every moment. But the cones have been tilted by the rotation into a great curving chain, and the chain bends around, and the open ends lead, step by lawful step, back to where you started. You walk forward the whole way and arrive behind yourself. This is why physicists could not just laugh it off. A man riding this loop never cheats. He never exceeds light speed. He never travels backward in his own experience. Every individual move he makes is the most ordinary move there is, forward into the next instant. It is the global shape of the universe, the way all those local cones are tilted and strung together, that closes the path into a ring. So the time loop is not a glitch laid on top of the physics. It is the physics, viewed from far enough back to see the whole staircase curve. Einstein understood every step of this immediately. He had built the machine. He knew the cones, knew the dragging, knew it all in his hands. Which is exactly why, when Gödel handed him the pages, He did not argue with the math. He flinched. Einstein did something that, for him, was almost an admission of fear. He wrote it down. When Gödel's result was published, Einstein was asked to respond to it in print, in the same volume. He could have praised it lightly and moved on. Plenty of great scientists fold an uncomfortable result into a polite paragraph and let it die there. Einstein did not do that. He addressed Gödel's universe directly, and the unease in his words is real and on the record. He admitted the problem had troubled him long before Gödel ever raised it. Back when he was first building general relativity, he had already worried about whether his equations might allow a traveler to influence their own past. He had felt the danger in the structure from the beginning. He had hoped it would not be real. And here was Gödel, his quiet friend from the walks home, proving that the danger was not just a worry. It was a solution. A whole consistent universe where the thing he had dreaded was simply true. Einstein's reply did not pretend the math was wrong. He knew it was not wrong. Instead, he reached for the only defense left to a man who could not attack the equations. He suggested that solutions like Gödel's, however legal on paper, might have to be ruled out for physical reasons. Maybe the real universe just does not behave this way. Maybe nature has some extra principle, not yet found, that forbids these worlds even though the equations permit them. Read that carefully because of who is saying it. This is Einstein, the man whose entire life was the faith that the universe is lawful and that the equations are the law. His deepest instinct, the one that drove everything he ever did, was to trust the math over his own discomfort. When his equations told him space bends and time slows, things no human senses had ever reported, he believed the equations. He followed them into territory that horrified other physicists, and he was right. Now his own equations had told him something, and for once he wanted not to believe them. He wanted there to be a loophole. He wanted nature to be kinder than the law he had written. The man who spent his life saying trust the math was, at the end of it, hoping the math would turn out not to mean what it plainly said. That is the measure of how bad this is. It is one thing for a result to frighten ordinary people who do not follow the equations. It is another thing entirely when it makes the author of the equations look for an exit. Einstein had no answer. He had only a hope, and he was honest enough to call it a hope and not a proof. That hope, that something out there must surely forbid these loops, has never gone away. Physicists are still chasing it now, still trying to find the law that closes the door Gödel opened. They have not found it. We will reach their best attempt later, and you will see how thin it still is. But Einstein's flinch did not even touch the worst part. He was worried about a traveler changing the past. He was bracing for paradox, for contradiction, for the universe tearing itself in two. What Gödel's loop actually does is far stranger and far colder than a contradiction. The universe does not tear. It does something much more disturbing instead. It refuses to let you tear it. Everyone, the moment they hear about traveling to the past, reaches for the same objection. It is the one that feels like a knockout. It feels so obvious that it must end the conversation. You go back. You find your own grandfather as a young man before he has children, and you stop him from ever having them. Now your parent is never born, so you are never born, so you never went back, so nobody stopped your grandfather, so you are born after all, so you do go back. The story eats its own tail. It cannot happen, the objection says, therefore the loop cannot be real. The whole thing collapses into nonsense, and we can all relax. It is a clean argument. Generations of people have used it to wave the problem away and sleep fine. And it is exactly the kind of clean argument Gödel built his life on dismantling. Because notice what the grandfather story actually assumes. It assumes that when you arrive in the past, you walk in free, that you can do anything you like back there, that you carry your full power to choose, untouched, into a moment that has already happened. The whole paradox depends on you being able to do something new in the past. Something that was not part of how the past went the first time. But the past did go a certain way. That is what makes it the past. If you really did travel to it, then your arrival was always part of it. You were there the whole time. The first time your grandfather lived through that day, you were already in the story, already standing where you stand, already doing whatever it is you do. There is no first version of the past without you and a second version with you. There is one past, and you are in it. So the question is not whether you are allowed to break it. The question is whether breaking it was ever on the table at all. And the answer the mathematics gives is the part that should chill you. The universe does not stop you with a wall or a warning or a paradox. It stops you in a quieter and far more total way. It simply never lets the gun fire. Every time you raise it, something intervenes, not magic, ordinary things. Your hand slips, the weapon jams, you lose your nerve at the last second. A stranger bumps you. You came back specifically to end this man, and you find, again and again, that you cannot, because the day this happened already includes you failing. You are not free in the past. You only feel free. You experience yourself choosing, deciding, trying. And the outcome was settled before you arrived. Because your arrival and your trying and your failing are all already woven into the single way that day happened. That is the door Gödel really opened. Not a universe that breaks under time travel. A universe that quietly forbids you from breaking it. By making your every choice in the past part of the past, it always was. Which leaves one question standing. The worst one. If the past holds you that tightly when you go back, how free were you the first time through? Sit inside that for a moment, because it turns the whole thing from a puzzle about machines into a statement about you. In a universe with these loops, a piece of the past is fixed in a way nothing in your normal life prepares you for. We are used to the past being fixed in the ordinary sense, that what happened, happened. But this is heavier. In a loop, the past has to fit with everything that loops back into it. It cannot just be settled. It has to be consistent with its own future, reaching around and touching it again. Think about what that demands. Imagine a region of space-time that a time loop runs through. Whatever happens in that region has to agree with itself perfectly, all the way around the loop, with no contradiction anywhere. The end of the loop has to match the beginning, because they are the same events. So out of all the ways that stretch of history could have gone, only the ones that close up cleanly are allowed to exist at all. The universe permits exactly the histories that are self-consistent, and not one other. That is the principle the people who study this settled on, once they stopped expecting paradoxes and started taking the loops seriously. Not impossibility, consistency. The loops are real, the math allows them, and the price is that the events inside them are locked into the one pattern that fits with itself. Here is why. That is worse than a paradox, not better. A paradox at least lets you off the hook. If time travel led to contradiction, you could say it must be impossible and walk away with your freedom intact, your past safely gone, your choices your own. Consistency takes that comfort away. It says the loop is fine, the loop works, you just are not free inside it. Your sense that you could have done otherwise, that the moment was open, that the future had not yet decided itself, that feeling is not evidence of anything. The events were always going to be the ones that fit. And now, bring it home. The way the math forces you to. If consistency rules the loops, what reason do you have to think your own life, the part with no loops in it, is any different in kind? You feel free right now. You feel the next minute as open, unwritten, yours to fill. But the man trying to shoot his grandfather feels free too, in every fibre, right up until his hand slips. His feeling of freedom and yours are made of the same stuff. The universe was just as certain of his failure as it is of whatever you are about to do. The loops are extreme cases. They make the locking visible because the past reaches around and touches itself, so you cannot pretend the future is undecided. But the lesson does not stay politely inside the loop. It leaks. It asks, quietly, what reason you ever had to believe that the open feeling of now was anything more than a feeling. If you find that hard to shake off, you're in good company, and you should not look away yet, because we are only at the edge of it. The natural escape is to say none of this is our problem. Our universe does not spin. The loops are somebody else's nightmare in a world that is not ours. So let us go and check the sky. There is an obvious way out, and it is worth taking seriously because it is true as far as it goes. Gödel's universe spins. Ours, you would think, clearly does not. So whatever horrors live in the spinning one, we are safe. The loops need that universe-wide rotation to build the tilted staircase of light cones. And if our universe is not turning, the staircase never forms, and the road to the past never opens. Case closed. We can admire Gödel's solution as a curiosity and get on with our lives in a universe where the past stays gone. This is the response Einstein himself reached for. Maybe nature just does not do this. And the good news, if you want comfort, is that we can actually test it. A spinning universe would leave fingerprints. So scientists went looking. If the whole cosmos were rotating, the rotation would show up in the oldest light there is. There is a faint glow left over from the early universe, soaking the entire sky in every direction, a kind of after-image from when everything was hot and dense. If the universe turned, that glow would not be even. It would be subtly lopsided, warmer in some directions and cooler in others, in a pattern that rotation would stamp onto it. There would be a preferred axis, a direction the whole sky leaned. We have mapped that ancient light with extraordinary care. We have measured its temperature across the whole sky, down to tiny fractions of a degree, and the verdict is clean. The glow is the same in every direction to an astonishing degree. There is no axis. There is no lean. If our universe rotates at all, it does so unimaginably slowly, far too slowly to build Gödel's loops, slower than the staircase of cones would ever need. So the escape holds. We do not live in Gödel's universe. The road to the past is not paved in our sky. If that is all you wanted, you can stop here and keep your past safely behind you. If this is the kind of thing that keeps you up, the channel goes here a lot, and you are welcome to come along. But notice what we have actually shown, and what we have not. We have shown that our particular universe does not happen to contain these loops. We checked, and the spin is not there. That is a fact about which universe we got. It is luck, or initial conditions, or the way our cosmos started. It is not a law, and that gap between we do not have it and it is forbidden is the whole game. Einstein did not want our universe to merely lack the loops by accident. He wanted them to be impossible, ruled out by some deep principle, so the past would be safe everywhere. In every universe the law allows. Gödel knew the difference. He had not built his universe to claim we live in it. He had built it to make a point that did not care whether we live in it at all. And that point survives the clean, quiet, loop-free sky we just measured, completely untouched. Here is the move that makes Gödel a genuine danger, and not just the author of one strange universe. He was not trying to tell you that you live in a rotating cosmos where you can visit your past. He knew you probably do not. The spinning was never the claim. The spinning was the proof of something much larger, and the something larger does not need our universe to spin at all. Watch the logic, because it is short, and it does not let go. Time travel into the past is sometimes possible. We know this now because Gödel built a universe where it happens, and that universe is fully legal under the laws of physics. The laws permit it. Not in our sky, but in a sky those same laws allow. So the rules of reality, the actual fundamental laws, do not forbid the past from being reachable. They allow it. There exists a lawful universe in which yesterday is a place. Now ask what that says about time. We believe time flows. We believe the past is gone, used up, annihilated the moment it passes, and the future does not yet exist. And only the thin, bright edge of now is real. That belief is not just a feeling. It is a claim about what is real. It says the past has no existence anymore. It is nowhere. It is nothing. But you cannot travel to nothing. You cannot fly a ship to a place that does not exist. If, in even one lawful universe, a person can journey to the past and arrive there and stand in it, then in that universe the past is not nothing. It is still out there, still real, a genuine location you can reach. The past did not get annihilated. It stayed. And here is the blade. The flow of time, the annihilation of the past, the idea that only now exists, cannot be a basic feature of reality if the very same laws permit a universe where the past is still there to visit. A real, fundamental fact about time would have to hold under those laws everywhere they apply. It cannot be true here and simply switched off over there in Gödel's universe, when both universes run on the identical rulebook. Either the passage of time is built into the law, in which case Gödel's universe should be impossible, or Gödel's universe is possible, in which case the passage of time was never built into the law. Gödel proved his universe is possible. So the flow of time is not in the law. That is the real gift he handed Einstein, and now you can see why a man would spend his last years trying to wish it away. It says, the thing you trust most, that time moves and the past is gone, was never a law of nature. At best it is a local accident. Something true about the particular universe we happen to land in. The way a coin happens to come up heads. At worst, it is not even that. At worst, it is something your mind does, not something the world does. Einstein wanted a principle that would forbid Gödel's universe and rescue the flow of time. He never found it. No one has. The loops sit there in the mathematics, lawful and unforbidden, and as long as they do, the passing of time has no firm place to stand in physics. Which raises the obvious challenge. If time does not really flow, why are you so sure it does? Why does every second of your life feel like motion, like a current carrying you forward out of a vanished past toward a future that has not happened? The answer is that this is not the first time physics quietly killed the flow of time. It had already done it once, years before Gödel, and almost no one noticed what had died. Before Gödel ever drew his rotating universe, an earlier discovery had already taken something away from us. Something so basic that losing it should have caused an uproar. It did not, because the thing it killed was invisible. We had never thought to name it. We just assumed it. The way you assume the flaw. It was the universal now. The idea that there is a single present moment shared by everything that exists. This instant, the one you are in, happening at the same time everywhere, across the whole universe at once. A cosmic line dividing all of reality cleanly into what has happened and what has not. The same line for everyone, everywhere. We never question that. It feels like the most obvious thing there is. Of course, there is a now. Of course, this moment is happening for you, and at the same instant, far away, some star is doing whatever it is doing in the same shared present. Past on one side, future on the other, and a single thin line of now sweeping forward for all of us together. Special relativity took that line away, and it did it with cold proof, not speculation. The discovery began with one stubborn fact about light. The speed of light is the same for everyone, no matter how they are moving. Run toward a beam of light or away from it, it does not matter. You measure the same speed. That sounds harmless. It is not. Hold the speed of light fixed for every observer, and something else has to bend to make room. What bends is time itself. Specifically, observers moving differently can no longer agree on what is happening at the same time. That is the piece that breaks the now. Two events that happen at the same moment for you can happen at different moments for someone moving past you. Not because one of you measured wrong. Both of you are right. There is no fact of the matter about which events are truly simultaneous, because simultaneity depends on how you move, and nature does not pick a winner. So the single shared now does not exist. There is no cosmic line dividing all of reality into past and future, because where you draw that line depends on your motion, and every observer draws it differently, and all of them are equally correct. The present is not one thing the universe agrees on. It is a personal slice, tilted this way or that depending on how fast and which direction you happen to be going. This was known for a long time before Gödel sharpened his knife. It was accepted, tested, used to build technology we rely on, and yet almost no one felt the floor drop, because the loss was abstract. So what if distant simultaneity is relative? It does not change your breakfast. The universal now died quietly, and we kept living as though it was still there, because losing it changed nothing we could feel. But it changes everything once you take it seriously. Because if there is no shared now, then now is not special. It is not the one real moment with the past dead behind it, and the future empty ahead. It is just where you happen to be standing. And that has a consequence that most people never let themselves follow. To see it, you only need one person moving, and a careful look at what their now contains. Make it concrete with one moving observer, because the abstract version slides off the mind too easily. Picture yourself sitting still, reading this. You have a now. Your now stretches out across the whole universe, your personal slice of this instant, including events unimaginably far away that you would call happening at the same time as you're sitting here. Fine. Now picture someone else walking slowly past you on the street, just walking. A few miles an hour, nothing exotic. Because they are moving relative to you, their slice of now is tilted ever so slightly compared to yours. The faster they go, the more it tilts. But even at a walking pace, it tilts a little. Up close, this makes no real difference. Their now and your now barely disagree about anything nearby. But the tilt is a tiny angle, and a tiny angle becomes a huge gap when you extend it far enough. So reach far away. Pick a place across the galaxy, billions of miles off. Because of that tiny tilt, multiplied by that enormous distance, the walking person's now out there can fall years away from your now out there. Events that are in your present at that distant place might be in the walker's past, or their future. from a difference no bigger than the direction someone strolls down the sidewalk. Now turn that around and let it land. There is a place far across the galaxy. For you, sitting still, something is happening there right now in your present. For the person walking toward it, that same something already happened. It is in their past, and for someone walking the other way, it has not happened yet. It sits in their future, still to come. 3 people in the same spot, at the same instant, on the same street. One says the distant event is now. One says it is over. One says it is yet to come. And nothing in physics lets you say which of them is right, because there is no privilege now to settle it. They are all correct. Sit with what that forces. If, for the person walking past you, a distant event is already in the past, then that event must be real. It must exist for there to be a true fact that it has happened. But that very same event, for someone walking the other way, has not happened yet. So it is real and settled for one walker, and not yet real for the other. And both of them are right, standing in the same place at the same time. The only way out of that knot, the only way to let all 3 observers be correct, is brutal. The distant event must simply exist, full stop, whether any particular person counts it as past, present, or future. Its reality cannot depend on whose now it falls into, because it falls into all 3 at once. It is there. It is part of the furniture of reality, sitting at its own location in space and time, and the labels past, present, and future are just where different observers happen to file it. And if that is true for one distant event, it is true for all of them. Every event, everywhere in all of time, exists in exactly the same way, just sitting where it is, which means the universe is not a now sweeping forward, leaving a dead past behind. It is something else entirely, something already complete. Here is the picture that physics keeps backing into, the one Gödel and relativity both point at from different sides. The universe is not a movie playing forward. It is the whole reel, all at once. Stop thinking of time as something that flows and start thinking of it as a direction, like the 3 directions of space. You can move left and right, up and down, forward and back. Now add a 4th direction and call it time. In this picture, the universe is a single 4-dimensional thing, fixed and complete, with space spread out in 3 directions and time spread out in the 4th. Every moment that has ever happened, or ever will, sits somewhere in that block, at its own location, just as every place sits somewhere in space. This is what people mean by the block universe, and it is not a fringe idea. It is the most natural reading of what relativity tells us. Once you accept that there is no shared now, that every event simply exists at its own spot regardless of whose present it falls into, the block is what you have left. Past, present, and future are not 3 different conditions an event can be in. They are just 3 labels for where an event sits relative to you, the way near and far are labels for where a place sits relative to you. Far away does not mean unreal, neither does long ago. In the block, nothing happens, in the sense we usually mean. The block does not change because there is no outside time for it to change in. It just is. Your birth is at one location in it. This moment, you reading this line, is at another. Your death is at a third. All 3 are equally there, equally real, equally fixed, like 3 cities on a map. The map does not show one city blinking into existence as you drive toward it, and another vanishing behind you. The cities are all there the whole time. You are the one moving across the map, and your motion does not bring the road into being. The road was always there. What we call the flow of time in this picture is not the universe doing anything. It is you, traveling along your own line through the block, lighting up one moment after another in your experience, and mistaking the lighting up for the moments coming into being. They were already there. You are a reader moving down a page that is fully printed, feeling each word arrive as if the words ahead were blank until your eye reached them. They were never blank. The whole page exists. You just read it in order. This is the universe that Einstein's own theories describe when you take them at their word. He knew it. Late in his life, when one of his oldest friends died, Einstein wrote to the family to comfort them, and what he offered was not the usual softness. He told them that the division between past, present, and future is a kind of illusion, however stubborn it feels. He meant it. To him, the friend had not vanished. The friend was still there, back along the time direction, at his own place in the block, exactly as real as ever. Just not here, in this slice. That is a strange and cold comfort, and not everyone can take it. But it follows from the physics whether anyone takes it or not. And it was this picture, the complete and frozen block, that Gödel saw all the way to the bottom of. Where the rest of us flinch and look away, he kept reading. Because for him, the block was not the end of the argument. It was the proof of something he had suspected about time all along. Something he was willing to say out loud when even Einstein would not. Gödel was not really interested in time machines. That surprises people because the loops are the part everyone remembers. But for Gödel, the spinning universe and its roads to the past were never the point. They were a weapon, and he was aiming it at a single target. He wanted to prove that time does not pass. Not that it passes slowly, or strangely, or differently for different observers. That the passing of time, the flow itself, the thing you feel every waking second does not happen at all. That it is, in the plainest sense, an illusion. A feature of how a conscious mind moves through the block, and nothing more. Out there, in reality, there is no flow, there is no moving present. There is just the block, complete and still, and the deep and total absence of anything happening to it. His argument was tighter than Einstein's gentle line about illusion, and that is why it cut deeper. Einstein offered the block as a comfort and a picture. Gödel turned it into a proof, and his proof used the loops. He reasoned like this. If time really flowed, that flow would be an objective fact about the universe, something real and out there, not just a private experience, a genuine moving present, sweeping forward, the same fundamental process everywhere. But we have already seen that relativity strips away any shared now. There is no universal present for the flow to consist of. Different observers slice the block differently, and none is privileged. So the flow, if it is real, is already in trouble. It has nothing solid to be made of. Then he drove the point home with his universe. Look, he said, here is a perfectly lawful cosmos, built from these same equations, where time loops back on itself, where the very notion of a steady forward flow falls apart completely, because the past and the future are tangled into a ring. In that universe, no honest person could say time flows in any straightforward way, and that universe runs on the same laws as ours. So the flow of time cannot be a fundamental feature of those laws. If it were, it could not break the way it breaks in his universe. A real, deep flow of time would have to survive everywhere the laws hold. It does not survive in Gödel's universe. Therefore, it was never real anywhere. Not there, not here, not in the moment you are living right now. That is the claim, stated as plainly as Gödel ever stated anything. The passage of time is not a fact about the world. The world is a block, finished and unmoving. The flow you feel is something that happens in you, a quality of your passage through the block. Like the wind you feel from sitting in a moving car. The wind is real as a sensation. There is no wind outside the car. The car is just moving through still air. And here is what makes it land with full weight. This was not the wild guess of an eccentric. This was Kurt Gödel, widely held to be the greatest logician since the ancient world. A man whose entire reputation rested on being unable to fool himself, on following an argument exactly where it led, even when the destination was monstrous. He had done that once before to mathematics, and what he found there had already shaken the foundations of human reason to dust. To understand why his verdict on time should frighten you, you have to know what he had already proven about truth itself. Years before he touched relativity, Gödel had done something that still ranks among the most disturbing intellectual acts ever committed. He had broken mathematics, gently, rigorously, with a proof no one has ever found a flaw in. He showed that the dream at the center of all rigorous thought was impossible. To feel the weight of it, you have to know what the dream was. For a long time, the greatest mathematicians alive shared a goal that seemed only a matter of time and effort. They wanted to put all of mathematics on a perfect foundation, a complete set of basic rules from which every true statement, every last one, could be proven. A system with no gaps, where anything true could be reached by following the rules, and anything false could be ruled out. Mathematics would become a closed and finished fortress, every truth inside it provable, nothing true left stranded outside the walls. It was not a foolish dream. It was the natural goal of the most careful thinkers in history, and they were closing in on it. The fortress was nearly built. Gödel, still young, proved it could never stand. He showed that in any system of rules rich enough to do ordinary arithmetic, there will always be statements that are true, but that the system cannot prove. Not because we are not clever enough yet, not because we need better rules. He proved that it is impossible in principle. Build any consistent set of rules you like, as powerful as you want, and there will be truths it can see but never reach. True statements forever beyond its proof. And worse, no such system can even prove its own consistency. It cannot, from inside, guarantee that it will never contradict itself. Let that sink in, because it is the deepest fact of his life and the key to everything else he did. Mathematics, the one place humans thought certainty lived, turns out to have holes that can never be filled. There are truths no logic can capture. The fortress can never be sealed. There will always be true things outside the walls, and no wall you build will ever enclose them all. This is the man we are dealing with. He did not find a small flaw in a particular system. He found a permanent limit on what proof itself can do. A boundary written into the nature of reasoning that no future genius will ever erase. And he did it by being the most honest thinker in the room, the one who would not pretend a gap was closed when it was not, the one who followed the rules past the point where everyone else stopped because the answer ahead was unbearable. So when this same man turns his attention to time and follows the equations of physics down past the point where Einstein himself flinched, and comes back to tell you that the flow of time is an illusion, and the past is still out there, and your sense of a moving present is a thing your mind does rather than a thing the world does, you cannot comfort yourself by calling him careless. Carelessness was the one sin he was incapable of. He broke the dream of mathematics by refusing to look away. He is doing the same thing to time. And the worst part? The part that keeps this from being one man's strange opinion is that the loops do not depend on him. They keep showing up. Other scientists, not chasing Gödel's point at all, kept stumbling onto the same door from completely different directions. That is the producer status update for this step. Other people kept finding the same door, and that is what should worry you most. If only Gödel had ever found a universe with loops in it, you could write it off as one strange mind building one strange world. But the loops are not his alone. They keep turning up in honest solutions to Einstein's equations, found by different people chasing different questions, who were not looking for time travel at all, and got it anyway. Before Gödel ever drew his rotating cosmos, another researcher had already worked out what happens around a spinning cylinder of dust. Take a column of matter, set it turning, and solve the equations for the space and time around it. The math came back with the same disease, close to a fast enough cylinder that light cones tip, just as they do in Gödel's world, and a path opens that loops back into the past. This was sitting in the literature already, quiet and unnoticed, before Gödel made the problem famous. The door was there. No one had walked up to it and named it. Then there are rotating black holes, and this one is not a thought experiment. Most black holes spin, because the stars that collapse into them were spinning, and spin does not vanish. When you solve the equations for a turning black hole, you do not get a simple point at the center. You get a ring, and the region around that ring, deep inside, is threaded with closed loops in time. In there, in principle, the past is reachable. We think real black holes have complications that may wall this off before you could use it. But the loops are written into the clean solution, the same way they are written into Gödel's, by nothing more exotic than rotation. See the pattern. Spin a column of dust, you get loops. Spin a whole universe, you get loops. Spin a dying star into a black hole, you get loops. The common thread is rotation, and rotation is everywhere. The Earth spins, the sun spins, galaxies spin. Spin is one of the most ordinary things matter does, and every time the equations meet enough of it, concentrated enough, the floor of time tilts and the road bends back. This is why the field could not treat Gödel as a one-time scare. One weird solution is a curiosity. A whole family of them, arriving by separate roads, is a message. It says the loops are not a flaw in one man's construction. They are something the law keeps allowing, again and again, whenever the conditions line up. The equations do not seem to mind closed time. They produce it freely, almost casually, the moment you give them a fast enough spin. And that changes the question. It is no longer, did Gödel make a mistake? He did not, and neither did the others. The question becomes, if the law hands out time loops this readily, why does our universe seem so free of them? Is there really a deep rule forbidding them, the rule Einstein prayed for, the rule that would make the past safe everywhere? Or have we just, by luck, ended up in one of the calmer corners where the conditions for loops never quite came together? No one knows. That is the honest answer, and it is not comforting. The loops are not rare exceptions, barely clinging to existence at the edge of the math. They are common in the solutions. They show up wherever you look hard enough. Someone was bound to ask the next question out loud. If the law allows these loops so easily, could a person build one on purpose? A physicist did exactly that. He sat down and drew the blueprint for a time machine in real equations and published it. The design is brutal in its simplicity. Take an enormous amount of matter, more than a star's worth, and pack it into a long, dense cylinder. Then spin that cylinder fast around its own length until its surface is moving at a sizable fraction of the speed of light. That is the whole machine. No moving parts beyond the spin. Just a colossal rotating column wound up to a tremendous speed. What does it do? It drags space-time around itself, the way every spinning mass does, but with such violence that the dragging overwhelms everything nearby. The light cones around the cylinder do not just tip a little, they get whipped around by the rotation until, close to the surface, they have rolled over so far that the future points partway back into the past. And then a traveler can use it. Fly a careful spiral around the spinning cylinder, close in, looping around it the right way, and you come out of the maneuver at an earlier time than you began. Circle it again, and you go back further. The cylinder becomes a dial you can turn to choose how far back you travel. This was not scribbled on a napkin. It was worked out properly, the geometry checked, the trajectories computed. As a piece of mathematics describing a possible object in the universe run by Einstein's law, it holds up. The blueprint is real. There is a catch, and it is a serious one. To make the loops form cleanly, the cylinder seems to need to be infinitely long. Infinite is not a length you can build. And once you cut it down to a finite tower, something you could in principle construct, the clean result starts to wobble, and it is no longer clear the loops survive. So this particular machine probably cannot be built as drawn, and the man who designed it knew that. But look at what the design proved anyway, because the lesson outlives the engineering problem. It showed that the time loops are not buried in some inhuman, universe-spanning structure forever out of reach. They live in something local, a spinning column, an object with a beginning and an end, sitting in otherwise ordinary space. The loops are not a feature of cosmology alone. Off in the deep structure of the whole universe, they cluster around concentrated, rapidly turning matter. Bring enough mass together and spin it hard enough, and the past opens up right next to you. The infinite length is the wall standing between the blueprint and the workshop. And the entire fight over time travel, from that point on, becomes a fight about walls like this one. Is the infinite length a real, fundamental barrier, a sign that nature truly forbids the machine? Or is it just a limit of this one crude design, a problem a cleverer engineer or a cleverer universe could root around? Because if it is only this design that fails, then the door is still open. And the most famous physicist of the age decided that could not be allowed to stand. He went looking for the wall that would close every door at once. Stephen Hawking did not like time loops, and he set out to prove the universe did not like them either. His instinct was the same as Einstein's, but he pushed it harder. Einstein had only hoped that something forbids these worlds. Hawking tried to find the something. He proposed that there is a law of physics, not yet fully written down, whose whole job is to prevent loops in time from ever forming. He gave it a name that tells you exactly what he wanted it to do. He called it chronology protection, the idea that nature actively defends the ordering of events, that the universe steps in to keep the past sealed off, no matter how hard you try to reach it. His argument for it was clever, and it turned the loop's own structure against them. Think about what has to happen for a time machine to switch on. At the instant it starts working, a path opens that lets things loop back. Now think about what is always present in empty space. Even a perfect vacuum is not truly empty. It seethes with tiny fluctuations, faint flickers of energy popping in and out, far too small to notice. Usually they amount to nothing. But give them a loop to run around, Hawking argued, and the picture changes. The moment a closed path in time appears, those vacuum flickers can circle it. A flicker goes around, comes back to where it started, adds to itself, goes around again, builds, comes back stronger, around again. The loop lets the energy reinforce itself over and over, with nothing to stop the pileup. And as the machine is about to switch on, that feedback runs away. The energy at the edge of the would-be loop screams toward infinity. The build-up becomes so violent that it warps space-time savagely right at the spot where the loop was going to close, and it tears the machine apart before the first traveler can ever use it. That is the wall Hawking proposed. Not a polite rule, a trap. Try to build a road to the past, and the very act of finishing it triggers a surge of energy that destroys the road as it forms. The universe does not forbid you with a sign. It forbids you with an explosion, perfectly timed every time. He summed up the hope behind it with a dry line that this keeps the universe safe for historians, meaning the past stays put. What happened stays happened. No one gets to go back and stir it. If this were proven, it would be the rescue Einstein never found. It would mean that even though the equations permit loops on paper, the deeper physics always steps in to stop them in practice. The solutions would be like flaws that nature patches the instant you try to exploit them. Gödel's universe would remain a mathematical curiosity, real in the equations but forever blocked from being built, and the flow of time, or at least the firm separation of past from future, would be safe after all. That is a great deal of comfort riding on one idea. And here is the problem with leaning on it. Hawking could not prove it. He believed it. He gave strong reasons for it. But he was the first to admit that his argument was not a finished proof, and to finish it would take a thing physics does not yet have. The wall has a crack in its foundation, and the crack is this. To prove that nature always protects the past, you would need a complete theory of how gravity and the quantum world fit together. We do not have that theory. No one does. This is the deepest unsolved problem in physics, and everything hangs on it. We have one magnificent theory of the very large, Einstein's gravity, the bending of space and time. We have another magnificent theory of the very small, quantum mechanics, the flickering vacuum, and the fuzzy particles. Each works beautifully in its own domain. But they do not get along. When you try to force them together in the places where both matter at once, the math breaks. It spits out infinities. It stops giving sensible answers. The two greatest theories we have cannot be made to shake hands. Now, look again at Hawking's wall. The runaway energy that destroys the time machine happens exactly where both theories matter at once. You have the quantum vacuum flickering, and you have space-time bending violently in the same tiny region, at the same instant. That is precisely the place where our physics stops working. So when Hawking calculated that the energy blows up and saves the day, he was working at the edge of a cliff, using approximations in the one regime where we already know our tools fail. He knew this. He stated it plainly. His argument was a strong suggestion, not a theorem. To turn chronology protection from a hope into a law, you would need the full theory of quantum gravity, and then you would need to prove, inside that theory, that loops are always blocked. Until both of those things exist, the wall is a guess. An educated, serious, brilliant guess. But a guess. And not everyone agrees with the guess. Other physicists, running the numbers in slightly different ways, have found cases where the runaway energy does not obviously blow up, where the feedback might stay tame enough to let a loop survive. The matter is not settled. It is actively, genuinely open. There are respected calculations on both sides. The honest state of the field is that we do not know whether nature forbids time loops or not. We only know we have not found the law that would. Sit with where that leaves us. The escape route. the one that would make the past safe, the one Einstein wanted and Hawking chased, depends entirely on a wall no one has been able to finish building. The loops are real in the equations, proven, sitting there in solution after solution. The defense against them is a conjecture leaning on physics we have not yet discovered. The threat is solid. The shield is a hope. That is not a balance that lets you relax. It is the opposite. It means that, as far as established physics can actually demonstrate, the door Gödel opened is still open. We have not closed it. We have only promised ourselves that surely, somehow, it must close. In a deeper theory, we cannot yet write. And while the theorists argue over a wall they cannot finish, at least one living scientist decided to stop arguing and start building. There is a physicist alive right now who has spent much of his career trying to build a real machine to reach the past, and his reason for it will stay with you. When he was a boy, his father died suddenly. Young, healthy, gone with almost no warning, and the loss broke something in the child that never fully healed. He decided, in his grief, that he would find a way back. Not as a fantasy, as a life's work. He poured himself into physics, into Einstein's equations specifically, because somewhere in them he had read that time was not as fixed as everyone said, and he wanted to find the place where it bent enough to let him return to his father. His idea grew out of the same physics we have been tracing, but with a twist. We have seen that spinning matter drags space-time and tips the light cones, but matter is not the only thing that carries energy, and energy is what bends space-time. Light carries energy too. So light, in principle, can drag space-time, just as mass does. His plan was to use it. His machine is a ring of laser light. Take a beam of light and bend it around into a circle, a closed loop of light chasing its own tail, using mirrors. Make it intense enough, and that circulating light should drag the space and time inside the ring around with it, the way the spinning cylinder did, but built from light instead of matter. Stack and strengthen the effect, and he argues you could twist the time inside the ring far enough to bend the light cones, and open, at least in a tiny region, the same kind of loop the theory keeps promising. He has published the work. He has worked toward building pieces of it in a real laboratory. Now, the honest report is that this is hard and contested. Other physicists have questioned whether the effect could ever be made strong enough to matter, whether a buildable ring of light could twist time by any usable amount. The machine that could actually carry a signal to the past, let alone a person, is nowhere close, and may face the same walls everything else does. This is not a man on the verge of stepping into yesterday, but strip away the question of whether his particular device will work, and look at what he is doing, because it is the point. He took the loops out of the realm of cosmic accidents and dying stars and infinite towers, and he asked the most human question there is of them. Could you make one here, with light, on a table, on purpose? He took Gödel's terrible gift personally. He read the same equations Einstein flinched from, and instead of flinching, he started turning mirrors. Whether or not his ring of light ever bends time, he proved something about the loops that the cold mathematics never could. They are not safely abstract. They are close enough to reach for. Close enough that a grieving man could spend his life building toward one and not be a crank, just a long way from done. And there is one more place the loops refuse to die. A place where you might most expect them to dissolve into harmless nonsense. The quantum world was supposed to be where the paradoxes finally broke the loops for good. It did the opposite. People hoped the quantum world would kill the loops, and it is worth understanding why that hope failed, because the failure is the strangest part of the whole story. The quantum world is where certainty goes to die. Down at the smallest scale, particles do not have fixed positions or fixed paths. They exist as a spread of possibilities, a blur of maybes, until something forces them to settle. So you might think, hopefully, that this fuzziness is exactly what would break a time loop. Send a particle around a loop into the past, and surely all that quantum vagueness would tangle the whole thing into contradiction. Surely the grandfather paradox, which we dodged before, comes roaring back when the traveler is a fuzzy quantum particle that cannot make up its mind. A physicist worked through this carefully and found the opposite. He took the rules of quantum mechanics and applied them to a particle traveling around a loop in time, and he asked whether the loop could always be made consistent. The answer was yes, always. No matter the setup, the quantum rules permit a self-consistent solution. The particle goes around, interacts with its own past, and the quantum blur arranges itself so that everything fits, with no contradiction left anywhere. Here is the eerie part. In the ordinary world, before it settles, a quantum particle explores all its possibilities at once. On a time loop, that exploration includes its own past selves. The particle, in effect, considers every version of the story, the ones where it changes the past and the ones where it does not, and what comes out the other side is always one of the consistent versions. The contradictory histories, the grandfather-killing ones, are not forbidden by a wall. They simply have no weight. They contribute nothing. Out of the full quantum spread of what could happen, only the self-consistent stories carry any reality, and the universe delivers one of those every time. So the quantum world does not break the loop. It does the same thing the larger world did, but more deeply and more strangely. It enforces consistency from the inside, automatically by the very nature of how quantum possibilities combine. The loop survives, the past stays reachable, and once again, the price is that you cannot use it to make a contradiction. You can travel back. You cannot change what was. The quantum rules guarantee it, not by stopping you, but by ensuring that whatever you do back there was always already part of how it happened. This was the last refuge, and it gave way. If the loops had collapsed into nonsense the moment you took quantum mechanics seriously, you could have said the whole thing was an artifact of using the wrong, incomplete physics, that the deeper quantum truth dissolves it. Instead, the deeper physics absorbed the loop and kept it. It found a way to make closed time consistent rather than impossible. The door stayed open even there. Step back now and look at the full shape of what we have. The loops appear in solution after solution. They cluster around spinning matter you could imagine concentrating. The wall meant to forbid them is an unproven guess waiting on physics we do not have. And the quantum world, the last hope for breaking them, swallowed them whole and declared them consistent. Through all of it, one thing has gone quietly unexplained. The thing you have been feeling this entire time. If time does not truly flow, and the past is still out there, then why, right now, does it feel so completely like motion? Something in you is keeping time, and it is not the universe. It is heat. Here's the puzzle in its sharpest form. The basic laws of physics do not care which way time runs. Write down the equations that govern a particle, a planet, a beam of light, and they work exactly the same forward and backward. Play a film of two billiard balls colliding, then play it in reverse, and both versions obey the laws perfectly. At the level of the fundamental rules, there is no built-in arrow, no marker that says this way is the future. The law is blind to the difference between forward and back, and yet your whole life is soaked in that difference. You remember the past, not the future, You grow older, not younger. A dropped cup shatters, and you never once see the pieces leap back together into a whole cup. Eggs do not unscramble. Smoke does not pour back into the cigarette. Everywhere you look, time has an obvious direction, a one-way flow you could not mistake. If the laws are blind to direction, where does that overwhelming sense of direction come from? The answer is one of the deepest in all of science, and it comes down to a single idea: disorder. Leave any system alone and it tends to get messier, more spread out, more mixed up. Never the reverse. Heat flows from hot things to cold things and evens out, and you never see it gather itself back into a hotspot. Order falls apart into disorder, and disorder does not reassemble into order on its own. This relentless one-way slide from order toward disorder is the most reliable trend in the universe, and it is the source of the arrow you feel. The cup is a perfect example. A whole cup is ordered, all its pieces arranged just so. A shattered cup is disordered, fragments flung everywhere. There are countless ways to be a pile of shards, and only a few ways to be an intact cup. So chance drives everything toward the shards, and essentially never back. The cup breaking is time moving toward disorder. That direction, the direction in which the mess increases, is what every clock in nature is secretly measuring. Not some flowing river of time, just the steady spreading of disorder. And this includes you. Your body runs on it. Your brain runs on it. Every memory you form, every thought you have, is a physical process that creates a little more disorder than it removes. Dumping waste heat into the world, ratcheting the mess upward. You remember the past and not the future because forming a memory is part of that one-way slide. Your sense of moving through time, of the past piling up behind you, is your own machinery riding the same slope down which the whole universe is sliding. So, the flow you feel is real as an experience, and it has a real physical source. But notice what that source is. It is not time itself flowing. It is disorder increasing. The arrow does not come from the law, it comes from the way matter happens to be arranged, sliding from order toward chaos. The feeling of time passing is the feeling of that slide, registered from the inside by a creature made of the same sliding stuff. Which means the thing you have been pointing to all along as proof that time flows is not proof of that at all. It is proof of something else wearing time's face. Look closer at the now itself, the moving present, and you find it is something your brain assembles, not something it receives. Start with a fact about your own senses that almost no one stops to consider. Nothing you experience is happening when you experience it. Light from this moment takes time to reach your eyes. Your eyes take time to turn it into signals. Those signals take time to travel to your brain, and your brain takes time to make sense of them. By the time you're aware of anything, it is already a fraction of a second in the past. You never experience the present. You experience a slightly stale reconstruction of it, always running a beat behind. It gets stranger. The different senses run at different speeds. Sound and light reach you and get processed at different rates. And signals from your foot have farther to travel than signals from your face. If your brain simply showed you each signal as it arrived, the world would be a smeared, out-of-sync mess. It is not. It feels seamless, unified, a single smooth now, and the only way to get that is for your brain to wait, gather the incoming signals, and stitch them together into one tidy moment before handing it to your awareness. The smooth present you live in is a construction, assembled slightly after the fact, edited to feel immediate. Your brain even fudges the timing. In certain experiments, it can be shown to place events in an order that serves the story rather than matching the raw arrival of the signals, quietly shuffling things so the finished moment makes sense. The now you experience is not a window onto reality. It is a production, a tightly edited cut built from delayed footage, designed to feel like live broadcast. And the flow, the sense that this constructed now is sliding forward, leaving the last one behind, that is part of the production too. Your brain builds each moment carrying a trace of the one before it, and a lean toward the one ahead, so that motion is baked into the very feeling of the present. You do not perceive a flow and then conclude, time is moving. The flow is manufactured and installed directly into the experience, so that there is no moment when you could step back and check whether anything is really moving at all. Put this together with what we found about disorder, and the picture sharpens into something hard to unsee. The arrow you feel comes from disorder increasing, a slope in the arrangement of matter, not a current in time. And the smooth flowing now you feel sliding along that arrow is assembled by your brain. A constructed and slightly delayed cut of reality with motion edited in. Two separate illusions, stacked. One supplies the direction, the other supplies the sense of movement. Between them, they produce the single most convincing experience you will ever have, the experience of time passing, and neither of them is time passing. This is why Gödel's claim is so hard to feel, even once you accept the argument. You cannot turn the feeling off. You cannot catch your brain in the act and watch the now sit still, because the construction of flow is more fundamental to your mind than almost anything you could use to inspect it. You are looking for the trick using the very faculty that is performing it. So the flow is in you. The question left is whether even a faint trace of it is out there, written into the world, or whether the world is exactly as still as the block says. Here is where the two threads finally meet, and the meeting is colder than either thread alone. We have the arrow, the one-way slide of disorder, which gives time a direction. And we have the block, the complete and motionless four-dimensional universe, in which nothing flows and every moment simply exists at its own place. These seem to fight. One says time has a clear direction. The other says nothing moves at all. The resolution is the part that should land hardest. The arrow is real, but it is local, and it is not a flow. Picture the whole block universe again, the entire history of everything laid out and fixed. Now notice that the matter inside it is not arranged evenly along the time direction. Toward one end, it is more ordered. Toward the other, more disordered. There is a slope of disorder running across the block, low at one side, high at the other. That slope is a fixed feature of the block, painted into it, not moving, just there. The way a mountain range is just there on a map. The arrow of time is which way that slope points. That is all it is. Not a river. Not a flow. A static gradient. A direction written across an unmoving landscape, like the way a hillside has a downhill direction, even though the hill is not going anywhere. We call the low disorder end the past, and the high disorder end the future. And we feel ourselves moving from one toward the other. But the block is not moving. The slope is not moving. We are reading it in one direction, the way you read a page from top to bottom, and calling that reading the flow of time. This is the reconciliation, and it dissolves the conflict completely. The direction we feel is real because the slope of disorder is really there in the block. But the movement we feel is not in the block at all. The law has no flow in it. The block does not change. What it has is a built-in lopsidedness, a difference between its two time ends, and creatures embedded in it experience climbing that difference as the passage of time. The arrow is a property of how the stuff is laid out. The flow is a property of how we read it. So both things Einstein and Gödel pointed at are true at once, and they do not contradict. Time has a direction, and time does not pass. The direction is local, a feature of our particular region, with its particular slope of disorder. The passing is a story our minds tell as we move along our own line through a structure that is, in itself, perfectly still. And now there is nowhere left to hide. The flow was your last evidence that the past is truly gone. You felt it move, so you knew the past was behind you, finished, annihilated. But the feeling of movement is manufactured, and the direction it moves along is just a static slope in a frozen block. The block does not erase the past as you pass it. Nothing erases anything. The block holds every moment in place, forever, all at once, which means the most ordinary belief you carry, the one underneath grief and regret and the whole shape of a human life, is wrong in a specific and personal way. Your past is not gone. It is still there. Take that literally because the physics means it literally, and it is stranger than any comfort or any horror you have prepared for. Every moment you have ever lived is still there, not as a memory, not as a trace left in your brain or a record in the world, as itself. Your first day of school is still happening at its own place in the block. The child you were still sitting in that room, the light coming through those windows exactly as it did. The best day of your life is still occurring, in full, never having stopped. The worst one too. They did not pass. You passed them. You moved along your line and left them behind you, the way a traveler leaves a city behind without the city ceasing to exist. This is what Einstein meant when he told his friend's grieving family that the dead are not gone, that the divide between past and future is a stubborn illusion. He was not offering a poetic kindness. He was telling them what he believed the physics implied. The person they had lost was still there, back along the time direction, at their own location in the block, alive in every moment they ever lived, exactly as real as the family standing at the graveside. Not returned to. Not waiting to come back. Simply still there. Where they always were. Where they always will be. Because the block does not let go of anything. You can feel how this cuts both ways at once, and that is what makes it so hard to hold. On one side, nothing beautiful is ever truly lost. Every good moment you have ever had is permanent, fixed in the structure of reality, beyond the reach of anything that could erase it. The flow you mourn, the sense that it is all slipping away forever, is the illusion. Underneath, it stays. On the other side, you are locked out of it. Still, there is not the same as still reachable. Unless you live in one of the looping universes, and our sky says we do not, you cannot walk back to those moments. They exist, and you cannot return to them, and both of those things are true at once. The past is real and sealed, present and untouchable. You carry the certainty that it endures and the certainty that you will never stand in it again, and you have to hold them together. And there is no comfort to be wrung from imagining it differently, because the same structure that preserves your past also fixes it. Nothing in those moments can ever be other than it was. Every regret is frozen exactly as it happened, permanent, unrevisable, sitting in the block forever in the one shape it took. The thing you wish you had said, and did not, is eternally unsaid, at its own fixed place, with no version of you ever getting to say it. This is the personal weight of the block, the part that stops being cosmology and becomes about your one life. You are a being who experiences a flowing now and a vanishing past, living inside a universe that has neither. Your deepest intuition about your own existence, that you are moving forward through time accumulating a past that disappears behind you, is a description of your experience and not of the world. And if the past is all still there, fixed and complete, then honesty forces the next step, the one almost no one is willing to take. Because your past is not the only part of your life sitting finished in the block. Your death is in the block too. It is there right now, finished, at its own place along your line, exactly as real as the moment you are reading this. This is the reveal the whole structure has been building toward, and there is no soft way to set it down. If the block is real, if every moment exists at its own location, regardless of whether it falls into anyone's present, then the future is not empty, waiting to be filled. It is already there. The future end of your life is as fixed and as real as the past end. The day you were born sits at one point on your line. The day you die sits at another. Both exist. Neither is more real than the other. The only difference between them is that you have already read one and not yet reached the other. We treat the future as open, unwritten, a space of possibility where anything might happen. That feeling is the same construction as the flow, the same trick of a mind reading a finished page one word at a time and experiencing the unread words as not yet existing. They exist. The block holds the future exactly as firmly as it holds the past. Your last moment is out there, at its location, complete in every detail, the time of it, the place, the way of it, all of it already a fact about reality, sitting and waiting for nothing. Because the block does not wait. It simply is. You can see why this is the thing a certain kind of mind cannot live beside. It is one matter to be told the past endures, that what is gone is not truly gone. There is mercy in that. It is another matter entirely to be told that your end is not ahead of you in the sense you thought. Not something that has not happened yet, but something that already exists, as settled and as actual as your childhood, just at a place on your line you have not read up to. Your death is not coming. In the block, it's simply elsewhere, the way a distant city is elsewhere. And your whole life is the road that runs to it, already laid. Every mile of it already there. And there is no escaping it inside this picture. No decision you could make to route around it, because the choices feel open only from inside the reading. The you who has not reached that moment experiences deciding, weighing, choosing, exactly as you experience freedom now. But the moment is already in the block. The choices that lead to it are already in the block. The slope of disorder fixes their direction, the geometry fixes their content, and the feeling that it might go otherwise is the same manufactured feeling that makes the now seem to move. Open is what closed looks like from the inside, while you are still reading toward it. This is the full cost of taking the physics at its word. Not just that time does not flow, that nothing about your life is unwritten, that you are a complete object in a frozen structure with a beginning and an end already in place, experiencing yourself as a traveler precisely because you can only ever read one moment of yourself at a time. One man followed this argument all the way to the bottom and believed it completely, and at the end of his life, the man who had proven time unreal was destroyed by his terror of what was coming. Gödel starved himself to death, and the shape of how he did it is the most haunting thing in this entire story. In his last years, the most rigorous mind of the age came apart along a single seam. He became convinced that someone was trying to poison him. The fear took him slowly and then completely, until he would not eat any food unless one person in the world had prepared it and tasted it first. That person was his wife. She became his shield against the poison he was sure was waiting in every meal. The one human being he trusted to stand between him and the thing he dreaded. Then she fell ill and went into the hospital for a long stretch, and the shield was gone. And Gödel, with no one left to taste his food, simply stopped eating. He kept refusing, week after week, growing lighter and weaker, the great logician reducing himself to almost nothing, rather than risk a poison bite. By the time the end came, he weighed barely more than a child. The cause of death was recorded in plain clinical words. He had starved himself out of fear. Hold that against everything he had argued. This was the man who proved, to his own complete satisfaction, that time does not pass, that the future is as fixed as the past, that the moment of his death already existed in the block, settled, real, no more avoidable than yesterday. By his own deepest conclusion, the thing he was so terrified of was not coming toward him out of an open future. It was simply already there, at its place on his line, as it had always been. His philosophy offered him, in principle, the most complete possible release from the fear of death. If the future is already written and time does not flow, then there is nothing to dread approaching, because nothing approaches. There is only what is, and it did not save him. The man who saw deepest into the unreality of time died in raw animal terror of his own future, refusing food, certain that something ahead of him meant to do him harm. The block universe was an idea he could prove. The flow of time was a fear he could not escape. Whatever he had demonstrated on paper, his mind went on living the way every human mind lives, dreading what was to come, gripped by a tomorrow he had supposedly shown could not truly be on its way. There is a terrible lesson sitting in that, and it is not that he was wrong. Nothing about his death refutes his logic. The block can be exactly as real as he proved, and he can still have died afraid, because the fear does not live where the proof lives. The proof lives in the part of the mind that follows arguments. The fear lives in the part that builds the flowing now and leans always toward the next moment, braced for what it brings. He had reached the floor of the argument with the clearest reasoning a human has ever managed, and it could not reach the place where he was afraid, which leaves you, the one still reading, in exactly his position, holding the same two things that tore at him. You have followed the argument now as far down as it goes, so look at what it actually leaves you with. Two old men used to walk home together, and one of them handed the other a proof that time does not move. We can finally say plainly what that proof has done to the question we started with. The flow of time is not protected by any law we have found. That is the whole of it, said straight. We went looking for the law that would make the past safe, the moving present real, the future genuinely empty and open. We did not find it. We found instead that the equations permit universes where the past is a place you can reach. We found those loops turning up again and again in spinning dust and spinning stars and rings of light. We found the wall meant to forbid them standing unfinished, a hope leaning on physics no one has written. No one. We found the quantum world, the last refuge, swallowing the loops and calling them consistent. And we found that the flow you feel so certainly is built from a slope of disorder and a trick of the mind, neither of which is time itself moving. So, the safest thing you believe is the one thing physics will not back. Not the bending of space, not the slowing of clocks. Those it confirms. It is the plain conviction underneath your whole life that time passes and the past is gone. That has no firm ground left to stand on. The law is silent where you were most sure. It protects no flow. And here is what that means for the moment you are in right now, this one. Reading this line. It is not a fleeting edge between a dead past and an empty future. It is a place. It exists, at its location, the way every place exists. The moment behind you, the one you were in a breath ago, still exists too. Exactly as real, not gone. Just no longer where you are reading. And the moment ahead, the one you are about to enter, already exists as well. Already finished, waiting for nothing, while you read towards it with the feeling that it has not happened yet. You will not be able to feel any of this. That is the last thing to understand. Gödel proved it and died afraid. You can follow every step and still walk out of here certain that time is flowing, that the past is gone, that the future is open and yours to make. The mind that builds the now will keep building it, no matter what you know. The flow will keep feeling like the truest thing there is. But now, underneath that feeling, you carry the other thing, that every moment you have lived is still there. That every moment you have left to live is already there. That you are not a spark moving along a fuse, burning the past away behind you. You are a whole life, complete, laid out and fixed in a structure that does not move, experiencing itself one moment at a time and calling that experience the passage of time. The two old men finished their walk a long time ago. Or rather, they are still finishing it. Somewhere back along the time direction, in a moment that never stopped. The famous one talking, the quiet one listening. The proof already passed between them. The past already permanent. The way it has always been. You are in one of your moments now. It is still here. It always will be.